Hello, hello. Good afternoon, good morning. Welcome wherever you are to the episode where we're going to explore a bit about hosted control planes in OpenShift Hypershift. That should be a pretty interesting topic. So let's get started as we always do with the newsletter. Let me jump in here and share my screen. Share screen, entire screen. And we are looking for that one. You should see the newsletter now. So remember, as always, if you're interested in following along in the newsletter, being updated when things are changed or when things are made available, definitely come to cilium.io/newsletter. Drop your email address in there at the top, and you will get access to these things that are as they are delivered. This is the newsletter episode number 65, and there's a lot of really interesting stuff in there. So let's jump in. One of the first ones that we talked about actually at the eBPF Summit was the Hello eBPF, writing a Linux scheduler in Java with eBPF. That's pretty neat. This new SCEDX stuff is actually one of the newer frontiers in leveraging eBPF for technology inside of the Linux kernel, which is pretty cool. Next thing up, we have noisy neighbor detection with eBPF, using continuous low overhead instrumentation of the Linux scheduler and coverage from InfoQ. We have what insights can eBPF provide into real-time SSL and TLS encrypted info. Actually really just pulling data back from what's actually happening at that layer. Pretty cool. A new eBPF load balancer from scratch. Is this from... Oh, this is somebody else entirely. That's cool. Leveraging XDP. Because, Liz Rice did a talk that was actually very similar to that. I thought that was actually pretty neat. In the ecosystem, eBPF is critical and how it's getting better. eBPF Summit provides data-driven revolution. eBPF Cilium on FHIR, a Star Wars story. There was some really interesting stuff in here I wanted to jump into. There we go. This is in French, but you can translate it. Create 511 interconnected Kubernetes clusters with Cilium cluster mesh. This is a 4-part series. I'm kind of impressed that, this is a lot of work, first of all. Like getting everything deployed and configured. I'm super impressed with how this has been done. And then you have to do it 511 times. Yeah. Wild. Definitely check that out if you're interested. And then I think there was another one that was actually something about Doom, the video game. Here we go. The Doom was presented at the Linux Planners Conference last week, a perfect example of this co-evolution from experimentation with games. Check out the recording for all details. It's pretty neat. With both Snake and Doom moving into the kernel. I love it. All right. The next thing I want to talk about is... So there is a docs page for Hypershift, and it's underneath the OpenShift organization, and that's here. And I kind of wanted to talk through kind of the architecture and like what I see people using it for and what's really interesting about it. So say you're in a world where you have a pretty significant investment in storage and hypervisors and all that stuff, and you have been using them for perhaps over vSphere or for OpenStack or for Citrix or whatever, and you're interested in leveraging that investment, but moving more toward a Kubernetes ecosystem or more toward Kubernetes environments. And the question is, how can you make use of those that bare metal investment, right? Like how do you make use of that rack of equipment in a way that can actually allow you to stand up and deploy OpenShift clusters kind of on demand for clusters. I mean, for consumers within your organization. So say, for example, you have different departments and you want to be able to provide them like maybe a dev cluster, a prod cluster, etc. You're thinking about Kubernetes, you're thinking about these OpenShift clusters as a means of thinking about it as capacity rather than anything else, right? So the capacity for this stuff is going to be made available. It's going to be made available in a way that you can actually provide it to your departments, like directly. But you have all of this investment in hardware and the underlying switching fabric, et cetera, et cetera. So like, how do we actually make use of this? And this is one of the areas where OpenShift has really stepped up its game. And what you can do, which I think is actually super interesting, is you could set up an OpenShift cluster that encompasses all of those bare metal nodes, those really big, beefy, tons of memory, tons of CPU, tons of I/O, bare metal nodes. You can create one OpenShift cluster, and then on top of that OpenShift cluster, deploy all of the components necessary to stand up this technology, Hypershift. And that would include stuff like, OpenShift data foundations, a reasonable CNI that has like a load balancing mechanism, what else? Like those sorts of things. Like you also have to have, so you have to have storage, you have to have a CNI, you have to have KubeVirt deployed if you want to make use of this in a dynamic way. We'll talk a little bit more about that here in a second. You have to have all of those things set up in such a way that you can actually then make use of them. And then what ends up happening is that you can create these hosted control planes, which is basically what the Hypershift component will do. And these hosted control planes will run the controller manager, the API server, the scheduler, and expose them using your existing Kubernetes tooling into the underlying fabric, right? So now these new pods, these new API servers, these new controller managers, these new, all of the components of actually OpenShift itself are now expressed as pods inside of that base or underlying OpenShift cluster. And they're deployed into into their own namespace. And you will be able to see them operating there. And I think that's pretty cool. And what that will do, and basically what that means is that now all of the actual components that are necessary to, I see what's happening. So all of the components that are necessary to actually operate this this hosted cluster are deployed inside of your base cluster on those big burly VMs. What about the worker nodes, you say? Like what about those VMs what about those machines that make up the cluster itself? Because like as you know, in an OpenShift cluster, having the control plane is one thing, but you need all of those other VMs to actually host your workloads and etc. And in many cases, you need those other VMs to even just stand up an OpenShift cluster, because that's where ingress will get deployed, et cetera, et cetera. It still works in that scenario, because what actually ends up happening is leveraging the KubeVirt component, you can actually create what's called a node pool. And in that node pool, go ahead and deploy the you can actually create and dynamically define and create worker nodes that are going to be the node pool for the Hypershift directly. And the sweet thing about that is that you can actually set the memory and CPU, you can set the version of OpenShift, etc., on those worker nodes directly. And that enables you to basically dynamically scale the number of worker nodes, because what you're doing is you're creating KubeVirt VMs on that underlying beefy bare metal node cluster. You're creating KubeVirt VMs that are going to be associated with your hosted control planes. And that, in my opinion, is ridiculously cool, because basically what that allows is, at that point, you're in a scenario where you can scale these clusters, right? So if you wanted to like grow that node pool or even auto scale it, right? That's all within your domain. And you can actually create more of these virtual machines based on the capacity of those underlying beefy hardware nodes. And you're not actually allocating an entire huge beefy bare metal node to an OpenShift cluster directly. You're actually creating VMs on top of those that are within your quota range for that particular type of cluster. And that enables you to say, like, create multiple of these Hypershift hosted control planes, multiple of these Hypershift hosted clusters, and then create multiple node pools that can be task-based or focused on specific work that you have from a given department or for a capacity for a given application, etc. Allowing you to do a couple of really interesting things. One of the things that you're able to do with that, right, is that once you've got that deployed, you're able to actually you're able to dynamically scale within the capacity of those underlying nodes the clusters that you're going to create. And all of those worker nodes, in Kubernetes terms, we think of these worker nodes as disposable, right? We don't want these worker nodes to always be available. We don't want them to live forever. We want them to live to a certain point, and then it's okay if they expire, right? Now, because you're using KubeVirt, it's easy to actually reinstantiate these worker nodes. You're not relying on them to be around forever. You're expecting them to be recycled over a period of time. And that in itself is actually pretty cool, because it allows you a much better kind of life cycle for those virtual machines that you're creating. The control planes are going to run in a high availability mode on the bare metal nodes as pods. We know that we can host that on those underlying on that underlying core cluster. And then we can also deploy, leveraging KubeVirt, we can also deploy the actual worker nodes in effectively ephemeral KubeVirt containers, running virtual machines on those same bare metal nodes across the set. So you're leveraging OpenShift to be the scheduler. Like, it's doing a lot of similar things to what vSphere or Citrix or any of these, or OpenStack or any of these things would do. It's just the scheduling, the deployment, the dispersal of VMs, the migration of VMs, all of that stuff. That's actually all being managed by Kubernetes at that point, specifically by OpenShift and the KubeVirt virtualization model, rather than having like vSphere or any of these other tools do it. In my opinion, that is incredibly valuable. Like, it's an incredible space, and it's very, very cool how that actually works, because it really allows you to make use of that existing hardware, make use of that existing investment, and come up with a very cool, scalable, dynamic way of making use of that, while also providing OpenShift clusters for your consumers. There is another element of this, and it's just my own opinion. I'm going to share it with you anyway. But my own opinion, running long-lived virtual machines like your Exchange server, for example, inside of Hypershift, I'm certainly not convinced that it's entirely ready for that. We do have persistent storage. We do have like the ability to migrate virtual machines. We do have all of that capability, but I'm not quite sure that we have all of the necessary ability to understand, like, that we are able to give some guarantees around consumption and all of those things to those VMs. But it's only a matter of time until that's actually a real thing. But for now, in this OpenShift model, where you're going to spin up dynamic workers and you're going to enable them to be used and you're going to enable these VMs to get created and support a given hosted OpenShift control plane, I'm on board. That's great. If it dies, it dies, and you create a new one, etc. Right? It makes it very easy to actually manage. It's a much different promise than your Exchange server, right? The promise is these worker nodes, they are meant to be somewhat ephemeral. If I delete one or if I scale down, that should be fine. And if I scale up or create a new one, that should also be fine. And for a great degree, I think that actually it turns out to be true. So let's take a look at a Hypershift cluster coming up. Now, to explain what I've done here, let me actually turn that off, and I will add a new screen, present, share. Let's talk about what's happening in this screen. So there's a lot going on, but I want to take you through it. There's a lot of really interesting stuff happening in this particular scenario, so we're going to just kind of walk through how all of this works. So what I've got going on here is I've got a bare metal cluster effectively, but I'm using libvirt, and I'm leveraging that KCLI tool that we talked about in my last episode. And so what I've got here is I've got nodes. So I've got 3 control plane nodes and 5 worker nodes, and they're all deployed here on my underlying base hypervisor. And this is basically just running libvirt. And in this libvirt scenario, I've gone ahead and I've deployed all of that stuff, right? So if I do kubectl get csv-a, I can see all of the actual CSVs that I've got deployed here. I've got multi-cluster engine, and it's not the only way to deploy this. There's actually another way to actually deploy it, which I think is pretty useful as well. And I suspect it's actually where where OpenShift is actually going with the product. But there's another tool that's actually called RHACM. And RHACM includes, it's like the Red Hat Advanced Cluster Management. And that includes, as a component, multi-cluster engine v2.2. And that's actually a way to deploy multi-cluster engine. I've just deployed it like manually here, but I don't think it's actually necessary that you do so. You could actually deploy the RHACM, and then you would get multi-cluster management kind of by default, or and you would be able to enable it as a managed offering. So I've got that all deployed, and when I get that deployed, basically this means that I now have, let's take a look at our storage classes. So I now have the OpenShift storage classes already deployed here. I got my local storage piece. This is an interesting one because this is actually how I'm going to deploy ODF. So the first part is this local storage SC component. And what I'm going to do is when I create a virtual machine, I'm going to give it 2 disks, right? One is like for the root file system itself. And then I'm giving it another 200 gig disk on top of that is going to be used as part of this local storage component. This local storage component will be able to create local storage disks in that 200 gig range. But then the actual ODF storage cluster provider, that's what all of this stuff here is, will actually make use of it. And that's pretty neat. So that means we're going to stand up Ceph. And if you haven't played with Ceph, it's basically a distributed storage solution that allows you to use block like in the underlying host as a component of basically standing up a distributed file system called CephFS. So that's all pretty automatically configured. I mean, there's a little bit of work you got to do. You have to like define nodes within racks. You have to do that kind of stuff. But once all of that stands up, that gets you to a place where you now have storage that you can rely on that is available to the entire cluster. And then once you've got that startup, you've got to create the KubeVirt hyperconverged operator that will go ahead and stand up all of the KubeVirt components. Again, there's some labeling, there's some other things you have to do to make sure that all of that stuff is deployed correctly. But once you get that all wired up, then you have the Hypershift stuff. And that's pretty cool. So once you have all of that, the next thing you're going to want to do is actually deploy a hosted cluster. So I've actually got 3 workers nodes, a number of CPUs, amount of memory for each of them. And then if I go into Shift here, it'll get pods-a, it'll get cluster operators. So we can see that I have a hosted control plane, and Shift is actually my kube config for the hosted control plane cluster. Get nodes. Nothing yet. Still waiting for these nodes to come up. $132. What I'm looking at here is I'm just making sure that I have what I think I have. Oh, I guess I don't know what I have. I didn't define it, so it'll get. So that's 129.14/23. Okay, and then let's go ahead and edit 6 to that, get rid of those things. We want to disable kube proxy. Apply-F. And this will get Cilium deployed so that we can actually leverage Cilium inside of our hosted control plane and hosted control plane environment. What's the man about? Oh, that's fine. Okay, so we can do kubectl get pods -a. We can see Cilium EEOLM is pending in the namespace, and we're just waiting for these shift worker guys to come up, and then we should be able to see them. You see they're up. Okay, looks like that's all good. So here in a minute, I should actually start seeing nodes show up. So then we'll be able to see this here, and then we'll actually also probably play a little bit with the with standing up a node pool on KubeVirt. We'll try to get that going as well. While we're waiting though, let's just do this. Let's do this. Kernel get cluster operators. This actually tells us where we are in the world. So it's looking pretty normal. Kind of waiting for things to solidify. Things are tense. We have a challenge with our existing ingress controller on the underlying host. Let's see what other looks like. Oh, it's not bad. Got a bunch of running VMs. Got a bunch of CPU left. Got a little bit of memory left. Yeah, should be fine. Things are looking good. Waiting for that Hypershift cluster to come up. Looks like we've got a problem with the routing. We should be able to ping. That's working. That's working. Let's take a look at the logs on the HA proxy instance. -n KCLI infra. Ingress 1443. There's no servers available. Yeah, so it looks like we got a problem. Looks like maybe the MDNS stuff isn't working on the workers. Well, that may not actually work. So let's try doing this instead. This will be a little more fun. Let's do this. Let's do KCLI, delete, VM, shift, worker, 0. Yes. 1, 2. And now let's actually go ahead and try to deploy this in a different way. Let's try to deploy this with a Hypershift worker pool instead. So let's do kubectl get node pool -a node pool. Actually, let's do this. Get node pool. Let's see how it's defined. So this is a node pool current config, Hypershift cluster, hosted cluster shift, cluster name, auto repair. And what I want to do instead is I want to create this type. Here it says type none. I want to change that. So let's edit that. Node pool. Instead of none, which basically means that it won't try to use any technology to deploy it. Instead of using none, I'm going to set the type to KubeVirt. And I'm also going to add some other KubeVirt stuff. I'm going to fix the YAML-ifies. So platform tab, compute. That's correctly tabbed. Okay, so this should stand up instead of leveraging our underlying, basically creating an ISO and standing up a VM external to the cluster. What this should do, oh, it's immutable. Okay. I'll delete node pool shift -n clusters shift. And then let's edit this resource that we just created. We'll get rid of some things here. Under references, resource version, UUID. Get rid of the status. And go ahead and make our changes to the platform again. Drop that in there. Type. Okay. Right click that. I'll apply that shift pool. That should create our there are nodes inside of the Hypershift, the KubeVirt side of things. Good old get VMs. All right, let's see if this gets us there. Let's see here. Okay. There we go. I see a definition of it, but I'm not seeing it deploy. Hypershift, virtualization. KubeVirt clusters. Okay, so kubectl get pause dash n OpenShift CMD. So there's all our bird stuff. So why are we not seeing anything come up here? Let's see. I see vert handlers. I see the operator running. The operator 6. So we see it defined, and we don't see it doing anything. Okay. So cool. Dash n clusters. Like nothing's reading it. Why not? Oh, that's my problem. Gotcha. Edit. Posted. Yeah, that's what it was. My bad. Yeah. I didn't actually make the glue happen. I didn't tell the hosted control plane about the nodes. I just told the nodes about the hosted control plane. Scaling up to 3 replicas. Okay, so kubectl get machine set A and clusters shift. I think I've made these strong enough that actually I should be able to deploy these, but let's see what happens. I like this. I don't know what that's about. Labels. So shift, shift, shift. Provisioning. Now, one thing I did notice is you can do something like this. You can do exec ti-n clusters shift, and then you can jump into the actual VM. Now it looks like it's importing the image. So it's now creating the image on the underlying storage component. And once that's there, you should be able to see the next step, which is where it'll create the VM. And hopefully we'll be able to see the next part. And then I'm going to go camping this weekend. So I will be checking out of here and going to do that. Got a new helmet. That's very cool. I'm not doing motorcycle camping, although I would like to. That's not what I'm up to this weekend. I'm actually going camping with my fam, which will be super fun. Including my sister, which will be very cool. Let's see how far we can get with this. Potentially this should work, and then we should be able to actually see the running VM and show how this would actually work dynamically. All right, now we do get pods. We should see a different pod running. Okay, Kernel get -a. Got one running. Sure. I'm looking for HT. So there's our container running. Console domain. Oh, neat. No IP addresses at this layer. Well, I hope that this exploration was useful to you because I think it's actually a really cool technology. I think it's got a lot going on. And I think it's pretty fascinating. But unfortunately for me, I have to go and take care of a bunch of other work before this node comes up. Get VM-A log-in. I really have to go. Looks like it's actually starting up. Well, we're going to leave it go. But anyway, I hope you all have a wonderful weekend. I am off to doing a bunch of other stuff, and I hope that this was super interesting. I find this Hypershift space that OpenShift is into to be super fascinating and probably very rewarding. So we'll see how it goes. Anyway, I'll see you all next time. Thanks so much for tuning in.